Assalamu alaikum, this is Shazad Ahmed, and today what we are going to study, basically we are just going to study the topic of atomic structure, because there are so many students want they want the specific knowledge regarding the atomic structure and atom. And there are so many students, they were just thinking about what do you mean by atom and atomic structure. So we are here to study about these things. Okay, and now we are just here to focus on it, atomic structure. So my dear students, when you are going to study the basic atomic structure, or if you want to have one of the introductory knowledge of the basic atomic structure, then you must need to understand the concept of different atoms or a little bit background knowledge. So my dear students, the word atom is basically derived from atomos. What's the meaning of atomos? The word atomos is basically a combination of the two words a and plus tomos. Okay, atomos. So what is the meaning of a and what's the meaning of tomos? This is not the letter of English. Basically, in Greek language and in old scientific language, E is basically is the indication of not or without. You've also studied such kind of words in biology like anaerobic respiration, aerobic respiration, asexual reproduction, blah 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 blah. So A means absent, A means not, A means without. When you talk about the tomos, the word tomos, when you talk about the tomos, is basically it means the divide or break. So the old concept regarding the atom was, what was the old concept of the atom? The old concept of the atom was, atom are what? These are the basic concept. The universe is made of the unbreakable particle, means the particle that cannot be broken down, or the particles that cannot be broken down. The universe is made of the small particles called atoms. Basically, that concept was given by a Greek philosopher whose name was Democritus, and that concept was given by the Democritus. It's about 500 BC. So the atomos, the basic concept of the atomos is that these particles cannot be broken down further divide. Okay, atomos cannot be broken down and they are unsplittable. You cannot break them, you cannot divide them. Okay, broken, cannot be broken further. That was the old and rejected concept. That was the old and rejected concept. Okay, tomos means divide or break. or okay. So the concept that was given by Democritus, it's about 500 BC. It's about, this is the very old concept, and it's about 500 BC old concept, is before the parents of Hazrat Isa alayhi salam, if I'm not wrong. So that concept basically was a wrong concept. Why it is not considered as the correct concept? Because in our today's science, we can say that atom can further be divided into subatomic particles. Means the atoms can further divide it. The atoms can further divide it into particles, further particles. These are called electron, proton, and neutron, and there are so many other particles. But these are the three fundamental particles, and you will just focus on these things. I'm just writing ETC, etc., etc., etc. Okay, but what are the fundamental particles that are included in your syllabus? That is electron, proton, and neutron. So first of all, we are just going to make a chart here, and by the help of that chart, you all can understand the basic concept of atom here. So what kind of chart that I'm going to show you here? Okay, I'm just going to make one line here, like this one, and this one, this one, this one, and this one. Now I'm just going to write down the structures here, and by the help of that comparative chart, you can compare the data. So the first heading that I'm going to share here, I'm just making a small size of the text. The first heading that you must keep here, that is called subatomic particles. Subatomic particles. Okay, these are the subatomic particles that you need to understand here. And just, these are the subatomic particles. And what are the subatomic particles? These are the three main subatomic particles. What are they? Number one, electron. Proton. Electron, proton, and the last one, that is the neutron. Now just I'm going to draw the line here, and by the help of that line you may also understand the concept. What is the concept behind it? Subatomic particles, electron, proton, neutron. So now the first thing, their symbol. Okay, in chemistry we have the specific symbols. What are the symbol of electron and proton and neutron? I'm using the word R. Why? Now just I'm going to mention the symbols. Symbol of electron is E, or you may also use E with negative sign. We talk about the proton, small p, or E with positive sign, small n, n or and neutral sign, okay, and neutral sign. I will just draw that zero here on the index like this and not. Now the second line that I'm going to mention here is about their unit charge values, or comparative charge. In the books, it is also called unit or comparative charge. The original charge value is something different, but you must focus on one more thing here. Unit or comparative charge. Sorry. Unit or comparative charge, because we are here to compare that. The comparative charge on electron, just to compare that, because we have found from different kind of logical explanations and data, the comparative charge of electron and proton, this is always same. Like this is 1, this is 1, and this is 0, means the no charge. But it has been found that the direction of these two charged particles is always against one another. So it is called, why I'm saying against means one keep the negative sign and other one keeps the positive sign. Although they attract to one another, because these two particles attract one another and they have the same charge values. The actual charge value of electron and proton is different. Just we are here to compare the electron, proton and neutron to one another. Another thing that you need to understand here, their comparative mass. The comparative mass or the comparative or unit mass, this is also called unit or comparative mass. Why? Because we are just comparing electron, proton, neutron to one another. Unit mass or comparative mass here, I'm just making some more lines here. Unit or comparative mass. So just for the comparison, we have found one more interesting thing. I will just start from proton. The comparative mass of proton and neutron is always same. That's why they are regarded as one. Means they're both, the proton mass and neutron mass is always equal. But when you talk about the electron, it is considered as 1 over 1836. When you just round off that data, you will regard it as 1840. So what does it mean? It means just, let's suppose you have just one physical balance, and in this physical balance, if you put one proton at one side and one neutron at one side, it means their mass is always same. But in case of electron and proton, that I'm just going to show here, you have another physical balance, and in one pen you just put one proton, and at the other side you have to put 1840 electrons. So these 1840 electrons, they are equal to the mass of one proton. That was a concept that I need to present here. So one electron mass, when we just compare the substances to one another, that would be like this. Okay, so for the comparison, it means when you divide 1 over 1840, it means the mass, it is very 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 negligible. It is the mass of one electron, this is the mass of one proton, and mass of one neutron, although the masses are also different, but we are here to compare them one another. Now the second thing that you need to understand here, their location. So their location, just for the sake of, you need to understand location in an atom. Location in an atom. So my dear students, when you talk about the location in an atom, it's very simple. Electrons are found around the nucleus. They are just moving around the nucleus. Around the nucleus. Atomic nucleus. But when you talk about the proton and neutron, when you talk about the proton and neutron, guess where they can be found. In case of proton and neutron, where they are found? They are found inside the nucleus. Just you need to compare them in a very, very, very simple way inside the nucleus. So this is also one of the similarity. The unit of comparative mass of proton and neutron is same. The unit charge of electron and proton same, although their directions are different. That's why we use the negative and positive values. The position and location of proton and neutron is same. The most important thing that you need to understand here, the most important thing, now the quantity of these particles in an atom. I'm using the terminology quantity of particles in an Got it? The quantity in an atom. Let's suppose, just for the sake to understand these things, the quantity of electron and proton, they are always same. I'm using the term here. The quantity of proton and electron in an atom is always same. Okay, quantity of electron and proton are always same in an. You must focus on these sentences. Like, for example, one atom keeps one proton, it means it also has one proton. It means one proton, one electron, and one electron means one proton. The quantity of electron and proton in an atom is always same. But what about neutron? It varies. What about neutron? It varies. Okay, it might be more than the number of proton, less than the number of proton, and equal to the number of proton. It varies. Now I'm again writing one more thing here. I'm going to mention one of the chart. This will help you a lot to understand the basic concept. This will help you to understand the basic concept. But when you talk about quantity in an ion, we talk about the quantity of these particles in an ion. I'm using the term ion, and I'm going to mention the term here, quantity in an. Okay, the quantity in an ion, it differs. I'm using the term, there are two types of ions. We've also studied in your previous classes. Like in case of in positive ion, I'm using the term plus ion. The positive ion, this is called what? This is called cation. What is the name of positive ion? This is called cation. 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 Remember one thing. In an atom, the quantity of electron is always in an ion, sorry, in an ion, the quantity of electron is always less than proton. I'm mentioning the word less than. But in case of proton, in a positive ion, the quantity of proton is always greater than electron. But what about neutron? What about neutron? It varies. The same thing like in our last question that we have also mentioned here, that it varies. So we are just more focused about the quantity of electron and proton here, especially in positive ion. The same thing that I'm going to mention here. But in case of quantity of these subatomic particles, the quantity of these subatomic particles in a positive ion, that is, we know that in a positive ion the quantity of electron is always less than proton, but proton are greater than electron, and there is no role of neutron quantity always varies. But when you talk about quantity in a negative ion, negative ion, what about this? The quantity of these subatomic particles in a negative ion, I'm using the term here again. In positive ion, electron quantity is always less than proton. But in case of a negative ion, what will you consider? Electron is greater than proton. Proton is less than electron, and that is varies. So my dear student, this is one of the some fundamental facts about the structure of an atom. But the most important thing, there are so many atoms, but how can you identify these atoms? So we use a term which is called identity of an atom. This proton, basically, this proton number, the quantity of proton, this is also called the identity of an atom. I'm using another heading here. Identity of an atom. You may also say that this is the identity card or identity number of an atom as well as of an ion. Okay, how can you identify what kind of atom is this? Now, the identity of an atom or of an ion, basically this is the quantity of number or number of protons. This is called number of protons. This is one of the important thing. Number of proton. This number of proton is also called protonic number or atomic number. Protonic number or atomic number. Now this is one of the basic concepts that you must need to understand here. Atomic number. But when you talk about electron and proton, electron and neutron, there is no role of electron and neutron to identify such kind of things like that. They may help us, but the identity card of an atom, that is the number of protons, means how many protons are found in an atom or in an ion. Some last points. As we know that atom is what? Atom is also a matter. Basically, atom is the basic unit of matter. In our previous classes, we have also studied that the matter is made up of particles and which are atom, molecules, and ions. And these molecules and ions, they both can be made by the atom. So, what do you mean by that? Atoms are what? Atoms are what? These are one of the fundamental unit of matter. So my dear friends, you must keep one more thing. If they are fundamental particles or fundamental unit or basic unit of matter, it means they also keep mass because the quantity of matter is called mass. These are the material particles. So we use a term here which is called atomic mass. To calculate the atomic mass, is a technique or a machine is used. The machine is called mass spectrometer. Okay, but there is a technique that is used to identify the atomic mass. This is also called the nucleon number or nucleon mass. Atomic mass, this is also called nucleon number. Okay, atomic mass is also called nucleon number. Why it is called nucleon number? Because most of the mass of an atom, it is found inside the nucleus, means the quantity of proton and neutron. So there is no role of electron in case of the atomic mass. But when you talk about the proton and neutron, this is a sum of proton and neutron that you need to understand here. How can you identify the atomic mass? By the help of one thing, a simple way, because you don't have the mass spectrometer in your house or in your laboratory. So what kind of material you will use? By simple mathematics way, this is called the sum of proton and neutron. Okay, the nucleon number, which is regarded as the A, I'm just writing here, atomic mass is, it is basically, it is the sum of the quantity of proton and plus the quantity of neutron. If you know the quantity of proton and neutron, it means you are able to understand the basic concept of atomic mass. We will just solve the examples also, just to find out that what do you mean by that. The most important term that I'm just going to highlight here, and this is very, very, very important. Sometimes in your exam, a question can be asked, what is the ionic mass? Let's suppose the mass of an atom of hydrogen, that is 1. What about the ionic mass? This is called ionic mass. The mass of an ion. So my dear student, in ionic mass, when you talk about the mass of an ion, it might be cation or anion, might be cation or anion. Okay, the mass of cation or mass of anion. As we know that in case of cation and anion, the quantity of electron and proton, they plays a very vital role. But in case of cation or anion mass, there is no role of electron. The same thing you will find here, like the atomic mass is always equal to the ionic mass. Atomic mass is always equal to the ionic mass. It means the quantity of proton and neutron is also used to find out the ionic mass. If you know the atomic mass, it means you are able to find out the ionic mass also. Now that was the description that I have shared here. First of all, you need to understand these concepts. Then we'll move further. But along with isotopes, along with atomic structure, you must know one more thing. And the last thing that I'm going to share here, that is isotopes. Although there is another topic that I will also share, inshallah, on my YouTube channel, but you must focus on that thing. Isotope, what do you mean by the isotopes? Here, just a quick review. When you talk about iso and the tops. First of all, beta, the iso, the meaning of iso, that is iso. Iso means same. Okay, and in case of tops, just focus on P, and top means P. P means here proton. Just to identify that, how can you identify what do you mean by the isotopes? Isotopes means the atom of an element keeps the same number of proton but different number of neutrons. Okay, there are so many definitions. We will also discuss these definition. So there is no role of isotope in here. But isotope, when we talk about the isotopes in an atom, the number of electron and proton is always same. The number of electron and proton, let's suppose the number of electron and proton, when we talk about the number of electron and proton here, although there is no role of electron here, but we know that if we find out the number of proton, it means we can find out also the number of proton. So we can say that isotope means same proton, same quantity of proton, but different neutron. But different neutron. So the quantity of electron and proton, this is same, but in case of isotopes, the quantity of neutron is always different, or we may also write it varies. So just a little thing that I need to share here. Let's suppose I'm just going to tell you about carbon 12. Now the example, the atomic structure of example that I'm going to share here, that is carbon 12. Let's suppose I'm just going to talk about carbon 12. I'm just going to draw the structure of carbon 12 here. So how can I draw the structure like this? Let's suppose this is the structure of carbon, and again Again, just I'm drawing one more thing here. Okay. Now, three circles just to identify the structure of an atom of carbon. So, my dear students, in carbon 12, there are 6 protons. If there are 6 protons, so how many electrons are there? Definitely 6. The 2 electrons are found very near to the nucleus. They are called their nearest shell electron. And there are 4 more electrons like this one, the second shell, this one, this one, this one, and this one. And we know that these electrons basically they have the negative charges. And the most important thing, these electrons they are in continuous motion. Like I'm writing here. Okay. Now the most important thing when we talk about the carbon 12, it also keeps the 6 neutron. So this is basically what this 12 is the atomic mass or nucleon number. This is the mass of an atom. But how can I know that this is the mass? Because this is found here. Now this proton, I'm just highlighting by the help of this green pen. Now look at here, this is the nucleon number, 6 proton and 6 neutron, just 6 proton and plus 6 neutron. When we sum them, we will have the value 12, and this 12 is the nucleon number or atomic mass of carbon 12. So this is what, this is the nucleus that I have mentioned here. But what are these? How many electrons are there? 1, 2, 3, 4, 5, and this one is a 6. So there are 6 electrons. And how many protons are there? There are also 6 protons. So, my dear student, now this is the central part which keeps the 6 proton. It means it also keeps the 6 electron. Now this is called the atomic nucleus. And the region outside the nucleus in 2 red circles, these are called atomic shells that are found here. Now this is a summary of the unit of atomic structure that is especially found in IGCSE, GCE, or Adexel group. By the help of that summary, you can understand that what is the structure and what is the basic concept of an atom. So you must understand these things and memorize that comparative chart. By the help of that chart, you can understand the concept. We will also discuss in our next lecture regarding some more details of atomic structures, and we will also discuss them, and then we will just focus on how to understand the concept of electron, proton, and neutron by the help of that chart. Thank you very much. This is your teacher Shazad, and inshallah we are meeting tomorrow with a new lecture of this unit. Thank you very much. Jazakallah khaira. Assalamu alaikum wa rahmatullahi wa barakatuh.